Hello everyone, welcome back to Extramarks Smart Classes, a smarter way of learning. In the previous chapter, we have studied about the analytical method of vector addition. Now, in this topic, we are going to discuss motion in a plane with uniform acceleration. Uniform acceleration means here the acceleration in the motion will be constant. Remember one point, if I say acceleration is constant, acceleration is a vector quantity. If a vector quantity is constant, it means it should be constant in magnitude and direction both, right? So whenever the acceleration is constant, we can use the three equations of motion. Please quote, you can use the three equations of motion only when the acceleration is constant. In all other cases, you can use differential integration or whatever. But here I am discussing only the problems in which the acceleration is uniform, the acceleration is constant. Now, you know one thing, that let's say this is x coordinate, y coordinate, and the particle is changing its position from A to B. So initial vector is R1 and the final vector is R2, where R1 and R2 represents the position of the particle at A and B respectively. Let's say it has taken some time t to cover the distance. So here it is given the time difference to be t2 minus t1. So if you want to find the acceleration, this acceleration can be written as change in velocity divided by time taken, v2 minus v1 divided by t2 minus t1, where velocity is vector and time is scalar. That's why I put arrow on velocity and I have kept this as it is. So here you can write v2 vector minus v1 vector equal to a into t2 minus t1, right? Basically I am considering t2 minus t1 as t, where t is the time difference between the final point and the initial point. Usually I start my motion at t equal to 0. So the time at which the particle reached point B will be t. So I can write this as final velocity vector minus initial velocity vector equals to acceleration vector into time difference, where t is the time vector. Now if you want to use in scalar format, then you can use v equal to u plus at, right? Now remember one point, that these vectors, this vector representation is very important. Why? Because you know that when acceleration is constant, you can use v equal to u plus at, s equal to final position vector minus initial position vector, this is displacement vector, equal to ut plus half at square, and this is v dot v equal to u dot u plus 2a dot s. The third equation is scalar equation, because here we are taking the dot product of two, right? Now one thing to note over here, that you can use the equations in x, y and z directions also. You can use this v equal to u plus at in x direction, y direction and z direction. How? Final velocity in x direction equals to initial velocity in x direction plus acceleration in the x direction into time. Final velocity in y direction equals to initial velocity in y direction plus acceleration in the y direction into time. Final velocity in z direction plus initial equals to initial velocity in z direction plus acceleration in the z direction into time, right? And if you want to find the net velocity can be written as under root vx square plus vy square plus vz square, or I can write v vector equal to vx I cap plus vy j cap plus vz k cap. Okay. Similarly, I can write the displacement vector as initial final position vector minus initial position vector equal to ut plus half at square. Similarly, if I want to use it in x, y, and z direction, then I can write x displacement equal to initial velocity in x ux plus half x t square, y equal to uy plus half ay t square, uz plus half az t square. It means you can use the three equations in x, y, and z direction respectively, because the x coordinate does not affect the y coordinate and the y coordinate does not affect the z coordinates. The only link between them is time, that the entire motion gets completed at the same time. So the y coordinate and x coordinate has to change themselves in the same time only. You can use the three equations in relative format also. V final relative velocity equal to initial relative velocity plus relative acceleration into time. Relative displacement or relative separation equals to initial relative velocity into time plus half into acceleration relative into time square. As you can see over here. This V2 represents the final velocity and V1 represents the initial velocity. So we have written it as V equal to U plus AT. This average velocity can be written as total displacement by total time. So total displacement is nothing, it is final position, that is R2, minus initial position, that is R1, that will give you displacement, change in position, divided by change in time. So you can write R2 minus R1 equal to V average into T2 minus T1. Here you can write R2 equals to R1, V1 plus V2 by 2. That is average velocity, right? Now I am writing final velocity V equal to V equal to U plus AT. So I have used it as R equals to R0 plus UT plus half AT square. I can write this R minus R0 vector. R0 is the initial position vector, R is the final position vector, is equals to displacement vector equals to UT plus half AT square. Right? This is my displacement vector. Now, let's solve some problem on this. An object starts from origin at t equal to 0 with a velocity of 5 I cap and it moves in xy direction under the force which produces a constant acceleration of 3 I cap plus 2 j cap, right? Now acceleration is given to us, acceleration is 2 I cap, sorry 3 I cap plus 2 j cap. Initial velocity is given 5 I cap. The particle starts from t equal to 0. They are asking you have to find the y coordinate of the particle at time t equal to 1 second. Now, either you can use s equal to ut plus half at square in vector form, or you can use, they are asking only y component. So you can use initial velocity in y direction into time plus half into acceleration in the y direction into time square. Now, I am solving this question by both methods. So initially I am using the displacement vector, that final position minus initial position. I am considering the initial position of the particle to be origin. So the initial velocity is 3 I cap plus 2 j cap plus half into acceleration is initial velocity is 5 I cap, acceleration is 3 I cap plus 2 j cap into time, that is 1 square. So I got this is 5 I cap plus 3 by 2 I cap plus 2 by 2 j cap. This can be written as 6.5 I cap plus j cap. So they are asking only y coordinate. So y coordinate will be in 1, because you know that it is x component, this is y component. Similarly, if you want to find y component only, you have to take initial velocity in y direction. The initial velocity in y direction is 0 because there is no component in the y direction. You can see over here. So it is half into acceleration in y direction, that is 2, into time square. So you get 1 again. Okay. Now, in the second problem, they are asking you have to find the velocity of the particle at time t equal to 2 seconds. Now, for finding the velocity, you need to apply the first equation of motion in vector form, v equal to u plus at. Initial velocity is 5 I cap, acceleration is 3 I cap plus 2 j cap, and time they are asking 2 seconds. So you can write 5 I cap plus 6 I cap plus 4 j cap. So you can write this is 11 I cap plus 4 j cap. This is the velocity. If they are asking x component of the velocity, it will be 11. If they are asking y component of the velocity, it will be 4. If they are asking the net speed, then it will be under root a square plus b square. So it will be 121 plus 16. That will give you 137 root meter per second. This is the answer. Now, next problem they are given. A position of object is given by r vector equal to 3t I cap plus 2t square j cap plus 11 k cap. Now they are asking the velocity and acceleration. So you know that the velocity is nothing, it is rate of change of position vector. So it will be 3 I cap plus the differentiation of 2t square is 2 common, differentiation of t square is 2t, so it will be 4t j cap plus this constant 11 is constant, so differentiation will be 0. So this will give you 3 I cap plus 4 j cap, 4t j cap. Now they are asking acceleration. Acceleration is nothing, it is rate of change of velocity, so it will be 0 plus 4 j cap plus 0. So I can write this is 4 j cap. So this is a case of constant acceleration because the magnitude is coming to be 4 and the direction is always towards plus y direction. If you want to solve these types of problem, you can use the 3 equations of motion also, you will get the same answer. Now, find the magnitude and direction of velocity at t equal to 3 seconds. They are asking the magnitude and direction of velocity. So the velocity vector can be written as 3 I cap plus 4 into t j cap. You know the velocity is dependent on time. As time changes, velocity is changing. But here you have to remember x coordinate is not changing, only y coordinate is changing. So they are asking at t equal to 3 seconds. I can write 3 I cap plus 4 into 3, 12 j cap. This is the velocity which is going in the I direction and j direction. If they are asking speed, means they are asking magnitude under root a square plus b square. It is 144 plus 9, 153 root meter per second. Okay friends, that's all for this session. Hope you learned a lot. Thank you so much. Bye bye.